Welcome to the first video for your higher course of this year. What we're going to start by doing is looking back at one of the key topics from your National 5 course that we need to know the skills of and just refreshing our memory. What we're going to look at is solving quadratics. Specifically, what we're going to look at is solving quadratics using the quadratic formula and the discriminant to determine the types of roots that a quadratic can have. Now, think back to when we did the quadratic. They were generally written as ax squared plus bx plus c, and when we were looking to solve them, this was set equal to 0. Now, doing this, we had a formula that we were able to use called the quadratic formula, and it followed the form x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. In this, our b, our a and our c all come as the coefficients of our x squared, our x, and our constant at the end of our quadratic formula at the top. What we're able to do with this is determine the roots of the quadratic. Now think back to it. Think back to what a root means for the quadratic. If you think about sketching a quadratic on a set of axes, so your x and your y-axis is set up here, roots tell you about the number of times that the quadratic cuts the x-axis. So a number of times you get incidents like this. Now, with quadratics, there are 3 possible scenarios that can occur. One scenario is like this, where you cut it twice, you get 2 roots. Another scenario is where it touches it just once and then fires away again. So it could touch it just once like that, or it could be coming up the way and touch it just once like that. That there is what we call a single or repeated root. You could then have a third scenario where it's just pinging up in the air. So it's just up there like that, down there like that. It doesn't actually touch the x-axis at all. These ones here have no real roots. They introduce the idea of something called a complex root, but we don't deal with complex numbers until advanced higher, or at least not at this stage anyway, so we won't worry about that just now. What we'll focus on is determining the type. Now, when we have our quadratic formula, there's a wee key part in it that allows us to determine the type of roots that we've got, and it comes from this bit here underneath the square root. That there is called the discriminant. The discriminant takes the form b squared minus 4ac. We can use this to calculate the type of root that we've got within our quadratic based on the a, b and c coming again from our ax squared plus bx plus c equal to 0. Now, there are 3 possible scenarios for a discriminant. We can either have the discriminant bigger than 0, so we can either have our b squared minus 4ac equal to 0, or we can have our b squared minus 4ac is less than 0. Each of these determines a different scenario. If b squared minus 4ac is bigger than 0, think back to the formula. That means we're taking the square root of a number, so when we add or subtract it on to a negative b, we're going to get 2 possible answers. What this means is that we get 2 real roots. So this is the scenario where it cuts the axis twice. It's going to cut the x-axis in 2 different locations. If b squared minus 4ac equals 0, the square root part of our formula disappears. So we're left with negative b over 2a, which means that we get 1 single answer. This is our 1 real root scenario. So what this means is it touches the x-axis and then goes away from it, doesn't cross it at all. And a b squared minus 4ac is less than 0, means that we're taking the square root of a negative number, which you can't do without introducing the concept of complex numbers, something we're not going to do here. So in this case, we get 0 real roots, i.e. it doesn't touch the x-axis at all in any way, shape or form. So I'll show you a couple of examples of how this could work. So imagine I've got the quadratic x squared minus 3x minus 10 equals 0. I can determine the types of roots I've got here before I even look at factorising it to solve for them. And again, it's using b squared minus 4ac. Now, to start with, I have to identify my a, my b, and my c. I need to know what values they are. And we get them by just looking at the coefficients of each term and the constant at the end. Now, the key thing to remember here as well, whatever sign it is, it goes with it. So in this case, my a is going to be 1, my b is going to be negative 3, and my c is going to be negative 10. Once I've got these, I can substitute them in. So I get negative 3 squared, take away 4 times 1 times negative 10. solve both of these parts. So negative 3 squared is 9. So I'm going to be take away 4 times 1 times negative 10 gives me negative 40. 9 take away negative 40 is the same as 9 plus 40, which gives me 49. So I get a positive value. It's bigger than 0. So I can instantly say that I'm going to get 2 real roots. What I can now do is solve it. Now remember, to solve a quadratic, if it's a nice straightforward one like this and we're able to, we can factorise it straight up. So in this case, for x squared minus 3x minus 10 equals 0, got to remember we're looking for two numbers that add to the middle and two numbers that multiply to the end. Two numbers that multiply for negative 10 and add to give you negative 3. Well, in this case, what I get for that one is I get x minus 5 and I get x plus 2. And that equals 0. And from there I get my two answers. I get x equals 5 and I get x equals negative 2. There you go. That's me solved it. I know it's going to cut the x-axis when x is negative 2 and x is 5. Imagine I give you a second example now. Let's say we've got x squared minus 4x plus 4 equals 0. Again, I can determine my type of roots using my b squared minus 4ac. To start with, same drill. Identify my a, my b, and my c. Reading off of here, I know my a is from here, my b is from here, and my c is here. So my a is 1, my b is negative 4, and my c is 4. And then it's a case of substituting them in. So b squared gives me negative 4 squared. Take away 4 times 1 times 4. Negative 4 squared is 16. Then we take away 4 times 1 times 4. Gives me 16 again. Lo and behold, that's equal to 0. So my discriminant is equal to 0. What that means I'm able to say is that I've got one real root. So this is going to be the scenario where my curve touches the x-axis and no more. And again, to solve it at this point, if we're able to, we can simply factorise it. So x squared minus 4x plus 4 equals 0. I'm looking for two numbers, add to give me negative 4, and multiply to give me 4. Well, negative here, they have to add to and multiply to give me a positive, so they're both going to be negative. So I'll end up with x minus 2 squared equals 0. It's going to be the same bracket here repeated. So from that, I can say x equals 2. So it's going to cut the axis where x is equal to 2, or touch it, sorry, where x is equal to 2, and then bounce back off. Why don't I give you a third scenario now? So let's imagine we've got x squared plus 2x plus 7 equals 0. And again, I want to determine the type of roots using my b squared minus 4ac. First step, same as always. What are a, b, and c? And again, we get them just by looking at these parts of our quadratic. So my a is going to be 1, my b is going to be 2, my c is going to be 7. From that, we just substitute in. So I get 2 squared, take away 4 times 1 times 7. 2 squared is 4, so that's 4, take away, well, 4 times 1 is 4, times 7 is 28, which gives me negative 24. So I know then that that's less than 0, it's negative. So my discriminant is negative, which means that I'm not going to get any real roots. So I'm going to get 0 real roots from this one. Now in this case, when we get 0 real roots, we can't really factorise this without, like I say, introducing the concept of complex numbers, something we're not worried about dealing with here. But if it's a more complex equation, and I know I'm going to get real roots, I can use the quadratic formula for it. So let's imagine I've got 2x squared, take away 7x, plus 1 equals 0. And I want to solve this one. We start with our first step. A, B, and C. What are they? Well, in this case, reading off from here, I know that A is going to be 2, B is going to be negative 7, and C is going to be 1. So I can then plug it in. Now, I know I'm solving this one, so let's start by just introducing the formula to begin with. So x equals negative b plus or minus square root of b squared minus 4ac all divided by 2a. We've got our a, our b, and our c, so let's substitute in. So negative b, negative negative 7, so it's just 7. So then it'll be plus or minus the square root of b squared, so negative 7 squared, take away 4 times 2 times 1. That's then all going to be over 2a which is going to be 2 times 2. So we've got all the different parts of our quadratic formula. What we're now able to do is start simplifying these and working things out. So what I'm then able to say is, right, so 7 plus or minus the square root, and what I can do is do my discriminant in here. Negative 7 squared is 49. 4 times 2 times 1 is 8. So 49 take away 8, square root of 41. It's all over 2 2's, which is 4. So from this, I get two roots. I get that x equals 7 plus root 41 over 4, or x equals 7 minus root 41 over 4. From that, we can quite simply use our calculator to determine our answer. So x equals, well, the 7 minus root 41 over 4, what that gives me is an answer of 0.1492 and a whole spiel of stuff. And the 0 plus root 41 over 4 gives me 3.350 and a whole spiel of stuff. Question list will typically ask you to round your answer to one decimal place. So I'd go to 3.4 and x equals 0.1. And I've got my two answers. So this formula can be used to solve much more complex ones where we're not going to instantly really be able to know the factorization method of it. We need to know this. We need to be able to do this. So it's good to go and get some practice at this. Look back at your National 5 material and make sure you're up on solving quadratics using this formula and determining the types of roots.